Next, I'm going to talk about some non-parametric methods for multiple variables that are discussed in some of the videos that I've posted. The first method is the k-means method. You should look at the help page for this function and all functions before you use them. The k-means function is just k-means. As its first argument, it takes a data set that contains the columns that you want to use for your clustering. And as its second argument, you tell it how many clusters you'd like to make. If you also wanted to specify where to start, where the initial centers should be for this algorithm, you can do that. You can look at the help page to see how you do that, but k-means also just has a default. So if I run this, a bunch of stuff gets printed onto the screen. That's fine, and it's meaningful. You can look at it if you want. So what this says is the first cluster has mean fertility 80.55 for this particular data set, and mean agriculture 65.5, and mean examination 9.4. So we have the means of each variable for each cluster. That's useful. And here, this vector tells us for each of the data points, so each of these is a region in Switzerland, so it has a name. For each region, which cluster is it in, 1, 2, or 3? Okay. We have a measurement that has to do with how good the clusters are, how similar they are to each other. And then we also have something called available components. And what does this mean? Recall that when you have a data set, for example, Swiss, you can access a vector, a column from that data set by referring to it by its name, right? There's that vector of values, the column from the data set, the variable. But this $ command is much more general. It means attribute. Many types of R objects have attributes. If the R object is a data frame, then the attributes are the different columns. If the R object is, let's do another thing quickly, if it's a t-test, suppose I save the output of a t-test like this, and I'll just make up some numbers, doesn't matter what they are. Okay, nothing printed out because I saved everything that came out of t.test, I saved in an object called output. But now I can access attributes, parts of the function called the object called output. If I say output $statistic, it tells me the t-statistic. If I say output $p.value, it tells me the p-value. How do I know what to type in here? If I look for the help page for t.test and scroll down to value, it tells me all the different attributes of the output of this function. So when I run t.test, I can look up the statistic, the parameter, the p-value, the confidence interval, etc. So how does that apply here? If I save the output of my k-means algorithm as k-output, one of the values that I could look up, one of the attributes that the help page would tell me to use is called cluster. And this, if I run these lines of code, is just that clustering vector. It's a vector indicating which cluster each of the data points is in. You can use that to make a plot. So here I'm making a plot just of 2 of the variables. There were more than 2 variables used for the clustering, but I'm going to make 2 of them on the x and y axes. And I'm going to color the points according to what cluster they're in. And there we go. Here I'm taking advantage of the fact that each color corresponds to a number. So the numbers 1, 2, and 3 correspond to certain colors. And so if I don't really care what colors I'm going to get, I can just set col equal to the cluster vector, which has numbers 1, 2, and 3. And then I don't have to worry about choosing specific colors, although you can choose specific colors if you want to. Now I'm going to add a legend. There it is. I've specified it should be in the top left, and that the values, the labels in the legend should be the numbers 1, 2, and 3, because those are the cluster numbers. And then let me also fill these in. Remember, every color goes with a number. So if I have the numbers 1, 2, and 3, and I say fill, it colors them in black, red, and green, which corresponds to what happened in this plot. There's our graphic.